We're going to talk about alkyl halide structure and naming. Now, here's an alkyl halide, right? This is methyl chloride or chloromethane. We'll talk about how to name it later, but really we took CH4 and we substituted one of the hydrogens for a chlorine right here in the green. Now, this is the real first functional group that we've talked about. And the reason why it's called a functional group is because it makes this basic carbon chain functional. Now, how does it make it functional? Well, if we look at this, we can imagine that this electrophilic chlorine atom is going to be pulling electrons in this covalent bond towards itself. And that creates a dipole in this bond, making this a polar bond. And it creates a dipole in the molecule, an uneven distribution of electrons in the molecule. Now, if we have an uneven distribution of electrons in the molecule with some locations having more electron density and some having less, then we've probably created some nucleophiles and electrophiles in the molecule. And that's what happens in an alkyl halide, is that we have a partial negative charge on the halide, a partial positive charge on the alpha carbon being the carbon directly bound to the halogen, and that generates an electrophile and a nucleophile. Now, if we're looking at the electron density map of this molecule, we can see that the halide is more red, orange, greater electron density, and the carbon and the hydrogens are more bluish with less electron density. And this is a nice way to really think about organic chemistry and reactivity, which we'll get into more and more as the semester progresses, is trying to imagine molecules as really this unequal distribution of electronic energy with electrophiles colored one way and nucleophiles colored the other. And when you mix two molecules together, you can imagine red interacting with blue on another molecule as a electrophile nucleophile interaction. Okay, so here's our alkyl halide, and this we would call a methyl halide, right? The halogen is directly bound to an alpha carbon that has bound to no other carbons, and so this is a methyl alkyl halide. Let's see if I can get rid of this surfaces display, and let's show, this. We substitute one of those hydrogens for another carbon. This is an example of a primary alkyl halide, a secondary alkyl halide, and a tertiary alkyl halide. This is some general nomenclature of alkyl halides, or any type of functional group. Is the alpha carbon can be described as whether it's methyl, primary, secondary, or tertiary, and so we can call this a tertiary alkyl halide or tertiary alkyl chloride. If this was an OH group, we could call it a tertiary alcohol. Now, let's go beyond this sort of general nomenclature and try to name some of these alkyl halides specifically. So here's some examples that I've put up. And really, since you've learned to name alkanes, naming functional groups isn't really much harder. Okay. The first thing we're going to do, let's try to name this molecule here, is we're going to identify the parent chain, the parent carbon chain. How many carbons is it? Well, this is easy. 1, 2, 3, 4, 5, 6, 7, 8. So this is some sort of octane, right? So that's the parent chain. But it's not just octane. It's some sort of chlorooctane. So this is chlorooctane, right? We're naming the substituent here as chloro. And is there anything else you need to tell me about this molecule in order to draw it out? Well, where is the chloro, right? What position is it at? We could number this octane from this side, 1, 2, 3, 4, 5, or we can do it from this side, 1, 2, 3, and your instinct probably tells you we're going to number from this side. We want the first substituent, and in this case the only substituent, to be the lowest number. So it's better for this chloro to be at the second position than the 7th position. So this is 2-chloro-octane. Now let's go down here. What's this molecule? Again, we identify the parent chain. 1, 2, 3, 4, 5, 6, 7. This is a heptane, and on my piece of paper I write that parent chain because that's what my name's going to end with. I write it to the right side so I have room to put stuff in front of it. Now here we have two substituents here, a bromine and a chlorine. So this is a bromo substituent and a chloro substituent. Again, we want the first substituent to have the lowest number. So what do? We number from this side, 1, 2. Chloro could be 2. 1, 2. Bromo could be 2. It's a tie. What do? Well, we go by the alphabet. Okay, so bromo will have priority over chloro because B is lower in the alphabet than C. And so we will name this a 2-bromo. What is this? 6-chloroheptane. Okay, actually here I don't need this dash. We don't need dashes between letters. So chlorooctane and chloroheptane. Okay, what about here? We got a cyclic molecule. The parent compound has 5 carbons in it, and so we have a cyclopentane. That's my parent. And we have a chloro in front of it. So we have a chlorocyclopentane. Now with cyclic molecules, they're a little tricky about their numbering. How do I number this? Is that 1? Is that 1? Is that 1? Well, you can choose, right? And if there's only one substituent on here, we can just assume that the alpha carbon, the carbon directly bound to our halogen, is the 1 position. That's where we would want it to make it the lowest number. And so we could call this a 1-chlorocyclopentane, or it's correct if we don't even number the thing. Chlorocyclopentane. The chlorine's off of the cyclopentane. We don't really have to number it in that case. Okay, here's one with alkyl halide as a complicated substituent. And so we have to think a little bit about priority here. Now, since the alkyl halide is sort of present outside of this cyclic ring, we have to determine what's more important. Am I going to name this some sort of cyclohexane with an iodoethane as a substituent off of there? Or am I going to name this as a iodoethane with a cyclohexyl group? Well, as we start adding functional groups to our toolkit, we'll determine which ones have priority. But, you know, the alkyl halide has priority over just an alkane chain. So we want our parent chain to contain the halogen. And so we are going to try to find the longest continuous carbon chain that has this I in it, this iodine. And so this will be a basic ethane, right? We have 1, 2, right? Now this is going to be the number 1 carbon, 1, because it's directly bound to the iodine. And so this is an iodoethane, and it has a cyclohexane off of the 1 position. Whoops. Stop that. Okay, so this is a 1-cyclohexyl iodoethane. We called this the 1 position, again, because if ethane is our parent compound, we want that iodine to be at the 1 position. We got iodine coming off of there, and we also have a cyclohexyl group.